Good morning, good afternoon, good evening, wherever you are joining us for Digital Twins in Manufacturing. My name is Nicole Bamford, and I'm the moderator for today's event. On behalf of Leslie and the team, we thank you for joining us. This presentation will be a keynote presentation followed by an exclusive fireside chat, unpacking how Colgate-Palmolive have used digital twins to solve multiple manufacturing challenges. And will be given by Warren Pruitt, Vice President, Global Engineering Services at Colgate-Palmolive, Darren Haverkamp, Technical Director at Colgate-Palmolive, Jeremy Boren, Brand Manager at GrayMatter, and Carson Drake, Senior VP and Co-Founder at GrayMatter. And their presentation and discussions promise to be well worth the listen. Before we get started, here are some quick administrative points. During the webinar, if you have questions for the presenters, please submit them in the Q&A box on your screen, and these will be answered during the question portion of the session. Likewise, for any technical issues, please write them into the Q&A box and we'll get to them right away. The widgets on your screen can be resized and dragged around for your viewing preferences, and we encourage you to visit the Resource Center on your screen for additional content and resources we and our sponsors have provided for you. So make sure you're sitting comfortably, and I'll now hand it over to Darren so we can begin.
Good morning. My name is Darren Haverkamp, and for Hills Pet Nutrition, a division of Colgate-Palmolive. Been with Hills and Colgate for approximately a little over 25 years. I've spent all that time in our supply chain, various roles, most of them in manufacturing, from team leader on the plant floor to site director to two of our sites, and now am the technical director for the Hills division. And so today I want to take you on our digital twin journey, and I will be presenting along with Carson Drake from GrayMatter. But really what I'll be taking you on is a little bit more of our reimagined, end-to-end supply chain reimagined journey. And what we have been trying to do is find ways to reimagine how we work within the supply chain. How do we improve our throughput per labor hour? And really, how do we, and what does that mean? How do we take out really the dull, dirty, dangerous jobs with technology and digitization? And we found digital twin to be a great opportunity to do that. So we found one of our largest opportunities to be in how we measure and deal with quality in our pet food process. So let me kind of position this opportunity that we had. This in very simple terms is our process is our pet food process. And what that is first of all, we bring in raw materials into our batching process, and and those raw materials are variable. So we buy commodities. These could be corn, these could be meats, these could be rice, and they're variable based on that commodity. And so we have to understand that, and we have to deal with that in our process. We then bring it to our extrusion process, and extrusion is where we really convert those raw materials to a finished product. The problem that we have is after extrusion, we go into about a 30-minute drying process, and then we screen the product. We apply topicals to our pet food, and then we cool that product down to ambient temperature. This takes about 50 minutes from extrusion to cooling, and at the cooler is where you get your first product sample in the ability to test that product for its quality attributes. So you are 50 minutes into your process before you're able to test it, and then oftentimes you find out you have an issue, and then you have 50 minutes of product that may be not optimum or where you want it to be, and then you make changes. And so we found the opportunity to be, how do you know what that product's going to be in 50 minutes and make those changes now? So let me talk a little bit about historically what we've done. Historically, to start up an extruder, we would find out how we ran it last. And every operator, and I think in every facility in the world probably has their little black book. And they said, okay, when we ran this formula or this product, it ran at a certain level. And so here's where we want our moisture to be, fat to be, and whatnot. Oops. And this is how we'll start up next time. Well, that creates problems, because what you have is you have one person's opinion. You have just a limited amount of variabilities that person is basing their startup conditions off of, and raw materials change, times of the season change, equipment may change in the wear and tear it has on it. And so we wanted to be more predictable, and we wanted to take in all of those variables and really learn from those variables and predict at a higher level where that product was going to be in 50 minutes. And so we seeked the help of bringing in a digital twin to help with those predictions. And so the first thing we did is we worked with our company GrayMatter, and we helped them understand our problem, and we helped them understand all the variables that could impact that problem. And said, let's start first of all with how do you start? How can we be more consistent with how we start? And because in a startup, that's where you typically will have your biggest opportunity for lost absolute material loss, and your biggest opportunity to improve. And so we said, let's get our startups right. And so the goal was to convert out of the black book and into prescribed startup conditions based on the algorithms within the digital twin. So we got pretty good at that, and we started to really hone in on those startups, and started to ask the question next, okay, now that we know how to start up, why don't we continue this throughout the run? Why don't we begin to predict where our moisture settings should be, where our fat protein settings should be to deliver the best product throughout the run, and use that digital twin to help us not only with startups but throughout the run. And then eventually what we're learning to do is not only prescribe those adjustments for the operator, but to automate those decisions and to really close the loop. And so that you can close that not only are you prescribing where to put your moisture settings or your fat settings or your horsepower settings, but really to automatically change those within the program by itself to really take the decision making away from the operator. And that's currently where we're at now. But what I'd like to do now is hand it over to Carson Drake with GrayMatter, and he can really walk through the mechanics of how a digital twin works.
Thanks, Darren. Appreciate that. And we'll get into more of the operationalizing of the application here in a little bit and what's entailed there. So real quick about GrayMatter. So we started GrayMatter back in 1991. And we started off down in processes. So we're on the left here, you'll see the Purdue model from 1992 and now the ISA 95 model. But we started off down in SCADAs and automation and historians and putting in data collection systems, and then moved up. We've probably been in 10,000 plants at that level. Then we moved up to level 3, where we were putting in downtime collection systems and capturing scrap and quality systems and so forth. And then in the late 2000s, the iPhone and the iPad hit, and people started to want to Google their assets. So they started to think about moving data out of the plant into analytics. So we fired up a cyber unit over there on the left. And then nowadays, what we're doing, if you kind of think about level 3 and below, those are data generators. They generate the raw data and the contextual data that we're going to use to do this digital twin predictive analytics with. And up on the top, now the cloud has arrived, and machine learning and artificial intelligence has arrived, and we're sort of going back and mining these data collection systems to move to more predictive and prescriptive. Now this is a digital twin conference, so I wanted to talk just briefly about digital twins, and then we'll get into this technology called TwinThread, which we used and partnered with to conquer the Colgate application. So digital twin is kind of like the term real time. It means different things to different audiences, and it really, the type of digital twin that you have really depends on the use case. So there's a number of different types of digital twins. There's digital twins that are used in design, where you're creating assets using product lifecycle management systems, and they're sort of theoretical and design engineering oriented. So CAD systems and stuff like that for designing, equipment. There's digital twins used in simulation, where you're simulating an asset or a process to behave like a physical asset. Oftentimes that's used for training or simulating processes. There's also digital twins in industrial engineering, where you're sizing new lines and sizing plants before they're ever built, for production purposes, or even power output if it's a power-oriented digital twin. In our world, a digital twin for advanced predictive analytics is used first for an asset hierarchy. So, all of your plants, all of your lines, all of your extruders across multiple plants. And then we use that hierarchy to get the data ready for machine learning techniques. So contextualizing the data, normalizing the data, creating manufacturing context around that data. And a digital twin for us can be a machine, it can be an asset, it can be a line, it can be a process. And so that's what we think of in the analytics world when we think about a digital twin. And there's a lot of different types of digital twins depending on what area of industry you're in. Here's an example of a digital twin of a wind turbine. This is more asset maintenance oriented. So there's key parameters associated with the wind turbine and calculations and KPIs associated with power output and wind speed and so forth. Here's a digital twin for an oil well pad. And so this is creating KPIs for daily production of the well and gallons produced per month, and generating alerts if there's key pieces of the well pad that are under stress or under load or becoming unhealthy, those kind of things. And then here's a digital twin for an extruder. This would be like Darren and Warren are using. So you've got a process that's extruding something here. This is the digital twin. There's key parameters associated with it, whether it's running or not. What are the key parameters like temperatures and pressures and flows associated with that digital twin? And living on that digital twin is historical data. So there might be a year or two's worth of actual history on the twin. And then there's also new data coming through the twin. So we learn from the historical data how the various products behave and how the extruder behaves and different raw materials that affect variability in the process. And then once we learn, then we run new data through it to predict with. And so that's kind of the key with this industrial predictive analytics world, is you have to have some history in order to train the twin. And so if you think about a digital twin, the technology that we partnered with is this company called TwinThread. They're a veteran group of folks that have worked in industry for 20, 25 years. They've been using industrial data their entire career, and now they're doing it with cloud-based machine learning, artificial intelligence-based technology. And so here's a digital twin. And on the digital twin, the name of this company is called TwinThread. So you've got digital twins, and then you've got digital threads. Digital threads operate on the twin to get that data ready for machine learning and also monitoring assets in real time, sort of streaming analytics. So these digital threads, this is an example of one here. There's an input, we're doing some logic on it, we're creating an event, creating some context. Things that we want to know when we model a process or an asset or a product are things like what product is running. We want different models for every single product that's running on an asset. And in the case of Colgate, there's a lot of varieties of of pet food, and they're creating new formulas all the time. Things like modes, is it in a startup or shutdown mode? Is it a particular season? Things that are associated with your process that we may want to segment the modeling on. We definitely want to know when it's not producing anything. If it's not running, we don't really care about that data that's in there. We don't want to use that to train models with if it's not making anything. So we want context and normalization of the data, whether it's down or not. And then things like speeds and quality tests and things like that are good uses of digital threads on a digital twin. And then the next type of digital thread are the machine learning threads. So this is a different kind of thread. In the middle here are the modern machine learning algorithms. And what TwinThread does is make this easy to use, where you can apply this to industrial data. So in the middle here, there's different machine learning techniques. So, boosted decision trees and regression techniques and neural networks and those kind of things. And then on the front end, and this is key to scaling out, this is all automated. So automating the data prep and sampling and filtering and segmenting the data, instead of doing that with data wrangling and manual techniques, this is all automated. So these are threads, specific use cases that run on digital twins and use the historical data to train the algorithms. And then one of the algorithms will predict the best, and that'll be the one that we put into production to predict key parameters. In the case of Colgate, key quality parameters that they use to validate their products. And you can run multiple machine learning use cases on the same twin. So you might be working with quality at first, and then you might move to downtime and energy and those kind of things. And so that's it, digital twins and digital threads. And so TwinThread makes this really easy. It's an off-the-shelf predictive analytics platform, which is composed of digital twins and digital threads. And basically it's a cloud-based architecture. It runs on Microsoft Azure, and it connects to all kinds of different industrial data sources. So out there in manufacturing and in asset industries, there's historians and SCADAs and maintenance management systems and MES systems and IoT systems and smart sensors. And TwinThread makes it very easy in minutes to connect to this data and then bring it up into use cases, a number of use cases that are out of the box and configurable, as opposed to a data science project from scratch. And so it's a great technology. It's built for manufacturers and industrial use cases. That's the only thing they focus on, and we found them to be a great partner. And then finally, there's over 25 use cases built into the system that you can configure in days and get up and running. And so this really boils down to 4 main use cases. These are our workhorse use cases. We do these week in and week out with lots of different companies. And on the right-hand side, it's kind of mostly focused on manufacturing. So, OEE improvement or throughput improvement, which consists of reducing downtime, maintaining the speed of assets, their rated speed, and then reducing scrap or first pass quality. And then down below that is the quality improvement sort of thing, where there's a particular parameter or set of parameters that you measure and test. In the case of Colgate, you don't get a chance to test that till 50 or 60 minutes after the product's made. But predicting in advance what a quality parameter is going to be measured at well before it can be tested, and then more importantly, making recommendations to the users, to the operators, on what they can actually change to reduce the chance of you failing that test. And so that's what Darren will get into here in just a minute with regards to operationalizing. And then over here on the left, it becomes more reliability, maintenance, and facilities oriented. This wages one, we're doing a lot of projects where while maintaining throughput and quality, how do we do that and use less energy? Less gas, less steam, less electricity, and so on. We call these wages projects. So they're very popular. And then finally, the broader asset health. This is what a lot of people think of when they think about predictive analytics. Things like vibration analysis and anomaly detection, looking at assets and getting early warnings when they start to become unhealthy. So these are the things that we do all the time with customers, and Colgate is doing in multiple plants. So with that, Darren, I'm going to turn it back to you, and let me know if you need me to help with anything else.
Sure. Thank you. Thanks, Carson. Okay, so now I'm going to talk about, I'm going to walk you through how we operationalize the digital twin within our process. So we kind of set up the reimagined opportunity that we had, and then Carson took us through how a digital twin works. And now I want to talk to you about how we at Colgate are attempting to operationalize this digital twin within our process. So the first step is to utilize smart sensors wherever possible. So it's all about data. So within our historical process in that black book, a human mind can only accept a certain amount of data to make their decisions. Well, within the digital twin, you can put in. We decided just to flow in as much of the variables and as much of the data as we possibly could, up to and including sensing devices that are just starting to come online and really starting to progress very rapidly within the last years, and to take that data and to push that into the models as well to help to predict even more the output of our quality. And so we are using next generation sensors to do that. We are exploring inline NIRs to where we can real time provide quality feedback to the model every 30 seconds or every 1 minute versus our historical every 30 minutes. And also to use machine health sensors so that we can start to understand the health of the equipment and maybe how the equipment operates differently, therefore impacting the quality of the product differently as the wear and tear of that equipment goes on advances. The next operational input is data quality. The quality of the data is critical for both training the model as well as real-time streaming of the information. So the consistency of the inputs is also different. So when humans are taking quality checks, they may take that check, 30 minutes into the process this time, and then a break happens or something happens, and then you took it 15 minutes the next time, and then 45 minutes, and that inconsistency can really wreak havoc onto the consistency of the data. So our next step is to try to automate the quality check. So when I started the presentation, I talked about what are the opportunities, and the opportunities are to improve our absolute material loss, and also to eliminate or to improve our labor metrics. And what we have right now is a dedicated person every 30 minutes to going and getting a sample of product, running that product through a series of quality checks, and then analyzing that to make a change. And so that human is really dedicated to this process where they do a check every 30 minutes, and that check takes about 15 minutes to perform. Really, all that person is doing is performing the quality check and then reacting to the data. Well, the digital twin takes the place of reacting to the data. We now have to find a way to automate the quality check to take that entire operation away from the human and to fully automate it. And that's where you're going to find the true labor efficiencies, and that's our opportunity. Next is automation. So this is a big learning that we've had, and we're continuing to work on because change is difficult, and when we prescribe these changes to a technician to make, that technician wasn't always comfortable with those and wouldn't always rely on those prescriptions of change in the process. Well, we know that those changes through our data and through our experiences, those changes were almost always the correct change to make, but they weren't always being taken by the operator. And that really causes this process to take longer. And so one of the learnings we had is that we need to automate, we need to close that loop and automate the process as quickly as we can. And here's the kind of the revelation that we had is that we often strive for perfection, and we think that a change has to be perfect. Well, what we learned is it doesn't necessarily have to be perfect. If the digital twin doesn't give the exact prescription that it should have, and maybe it corrects itself with the next prescription, that's okay. It doesn't have to be perfect. It just has to be better than the historical human intervention, which it's proven itself that it has to be. And those are big learnings that you have to get through to your population. Next is to ensure visibility of the data. We need so there's a lot of information there. You don't want to provide all of that information. You want to provide just the right amount of information where you can react to not an overthrow of data, but the right amount of data to where you create the right KPI reports. You make those reports visible to the appropriate audience. A team leader may have a different need for that data than a technician, which may have a different need than the plant director. And then to quantify those improvements, because everybody wants to know, is it paying for itself? And so the ability to get that data visible and to quantify that is important. And then keep people in the loop. So we want to integrate this into our current HMI process, but not to overrun the technician with new screens, different way of looking at things. And we wanted to create a familiar, ubiquitous feel for the operators. And what does that mean? That means that we didn't want the operator to feel there was much different. We wanted them to have the information, but to not feel, oh, this is one more thing I have to learn. And similar to like the Amazon Alexa. Amazon Alexa is pulling maybe 1,000 apps to get the information that you as the end user needs, but you only know one. So that's what we tried to do. We tried to create a field to where they just know one thing. That's their HMI screen. They don't have to do anything different, but it's pulling from different parts of the process. Think differently. This, like I alluded to already, you got to create a culture that embraces new ways of working, and that's the most difficult part of this. Provide training and demystify the technology, and create yet another tool for operators. Again, they don't feel like it's a whole new thing they have to learn, but it's there, it's available. It's like Amazon. I look for it, it's available, and closing that loop is extremely important. Connected platforms. Integrate the platforms to enhance the value of the platforms involved. How do you get that twin thread information? How do you get it into your Wonderware screens? Get it into your ERP system so that it's again one consistent feel and look. And so those are kind of the learnings that we had on how do you digitize. Operationalize digital twin. How do you take all of that information, all of those inputs, and really feed the models? But when you close the loop, but when it comes back to the person running the screens or person running the process, they don't feel overwhelmed. And that was a significant challenge that we worked with GrayMatter on for quite some time to get that right. And then at the end of the day, this is how we operationalize it. This is a technician at the screen who's actually running 3 different extruders right now from their screen, which historically we haven't done. And they're taking. We used to have a dedicated technician per screen, and the loop's closed. They're taking the digital twin information. It's feeding right back into the process and closing that loop. And we just have the last piece of automating the quality checks, which will be done within the year, and then we will have a complete reimagined extrusion process. So what's next? We are also working on, as Carson alluded to, some different types of digital twins throughout Colgate. We're looking at energy optimization digital twins, utilizing our extrusion models and really expanding that potentially into soap extrusion and looking at that in Mexico, as well as scaling the pet nutrition twin, our digital twins to kind of optimize. How do you not just look at the current process, but how do you look at future formulas and predict how those formulas will run before you even bring them to the plant to really shorten the life cycle, the development cycle of a process. And I believe that's the end of the presentation. So open to maybe having some questions and some discussion.
Thanks, Darren, and thanks, Carson. I'm Jeremy Boren, GrayMatter's brand manager. So I think we'll move into the panel discussion next, if that works for you guys. A couple of questions here, and we'll get to some audience questions too. I see a few folks have posted some, so thanks for doing that, and keep them coming. We'll get to them here in a little bit. But Carson, I'll just start with you. I mean, we've talked a lot about how Hills is using digital twins to make predictions and using advanced analytics, but you're in a lot of different plants, a lot of manufacturing facilities all over the country. What are some other examples that people would be interested to know about how folks are using analytics and digital twins?
Sure. Thanks, Jeremy, and thanks, Darren and Warren. So I think one of the learnings, just to add to what Darren was saying, is in the beginning, several years ago, when we first started working with this machine learning technology, there was a little bit of an adverse feeling about the cloud, and so a lot of my tech talks and so forth were talking about the advantages of the cloud. I mean, this is where the machine learning algorithms run, and the beauty of it is you don't have to maintain your own data centers and computers and blade servers and stuff. The cloud really has infinite capacity and infinite memory, so it can expand and contract without you having to do all that work to accommodate the new algorithms, the machine learning algorithms. So that's the first sort of thing. And then as far as use cases, man, it's been great. There's been so many different use cases of this technology. I mean, we talked about the four big ones: throughput, quality, energy, and asset reliability. But the way that manifests itself is really in savings. So for example, we're working with a paper company that's putting coatings on packaging material, packaging paper. And by optimizing their quality, we can put the right amount of coating on the paper, but use less material in the process. So they're saving hundreds of thousands of dollars per line by reducing the amount of material that's used. As Darren mentioned, sort of, I call it right first time batches. So the ability to pass the quality parameters for a batch, and know whether you're going to pass or not well in advance. And, there's all kinds of different quality parameters that are tested, in food, it's salt and density and protein, and in chemicals and paints and so forth, it's pH and viscosity and color. And having the ability to know the outcome before you get there with enough advance notice to actually make changes to make sure you're in spec is pretty important, and huge savings can be gained by doing that. There's moisture in everything, so everybody, both in industrial processes and food processes, that moisture is a key element that needs to be managed. And so the outcomes are reducing material consumption, reducing scrap, reducing rework, maintaining speed and throughput across all kinds of different industries.
Thanks, Carson. So this next question is for Darren, and Warren, please, weigh in as well. But could you kind of talk about what it was like just for your team to work with a third party like GrayMatter to, leverage those analytics and to get those digital twins making those predictions for you. What was that process like? How long did it take? And kind of how did you set up that culture to know what the expectations would be?
So it takes. So the first thing we did is we really had to work to understand the opportunity that we have. So we understood it, but we had to help GrayMatter understand this is our opportunity. And really the challenge oftentimes in these type of technologies or this type of technology search is not to really search for the next shiny object, but to really search for what best fits your needs, what best fits the opportunities you have to address your problems. And so really helping GrayMatter understand, here's where we see opportunity, help us understand how a digital twin could help us in that area. And then really to dig into what data is out there that can help influence this. And we're the pet food experts, they're the digital twin experts, and saying, and so really kind of coming together and discovering what data it is that really influences that pet food process, and then how can we capture that, and then helping them understand, okay, this is how this data impacts this process, and really started to be, it's a cohesive effort to where we have our expertise, they have their expertise. You bring them together to solve that problem through many meetings of helping to understand the data and helping to understand the opportunity.
Yeah, and I'll just add to complement what Darren said, and then on a broader view. When we started our journey, let's say, of digitization in general, looking at the end-to-end supply chain and those opportunities, like Darren said, not chasing the next shiny object, but really digging into what technologies are going to provide the biggest benefit to our end-to-end supply chain. We realized very quickly, and this started, let's say, roughly 3 years ago, when we really started digging into that whole digital strategy. We realized very quickly, we're not an analytics company. We are a CPG. And nor are we going to try to become an analytics company in terms of, looking at how do we bring on board or train a large force of data scientists. We had to go out and partner with the expert. And like GrayMatter, like Twin Thread, they are the experts in this. They brought it to the table, and really then, as Darren said, it's really working together to bring what is our requirements to pair up with the technology that's going to give us that benefit. And it's been a very good relationship between us and GrayMatter. And as Darren said, now that this is kind of taken hold and really reaping the benefits in the Hills team and organization with the extruders that they're rolling out across all their sites globally. We've also looked at the benefits of, as Darren said, the soap making, and really looking at from going back as far, kind of bringing it to a bigger scale on soap making, not just extrusion, but looking at it from a standpoint of where we bring in raw materials all through the end of the packaging line. So that's kind of a bold move for us to go well beyond what we're doing, and then Hills is going to do the same as well once they get this rolled out on their extrusion. And then we also took it to energy management, which we're working on some packaging lines in Brazil and Mexico in terms of deploying this on for energy management as a digital twin. But I think the last point I would like to make is some technologies can be deployed fairly quickly. Others, when you start talking about machine learning and developing and getting those analytics and understanding the capability, Darren and I were talking about this the other day, and late last week, in fact. This isn't something, a digital twin, especially on a process, you're not going to be deploying in a matter of months. I mean, the initial work here was slightly over a year. Of course, the benefits we see are going to be very large in terms of scrap reduction, quality improvements, yield, and so forth. But something like this is going to take time. and you can quickly come to a failure if you try to push it too fast, just making the wrong decisions. And I think Darren and his team took the right approach, took the right amount of time, worked with not only the GrayMatter and Twin Thread teams, but also with their teams in the plants to make sure that this was done correctly. And so we are here, where we are today, which has proven very successful, because not only is Hills rolling it across their plants globally, but we're also deploying this technology to other use cases, throughout our various product categories and making systems.
Thanks for that, Warren. That's great context and insight. Carson, the next question is for you. Just could you tell us how a team should go about defining ROI when they're thinking about a project like this, just to set some good expectations at the front end?
Sure. Yeah, I think what I see as a success factor early on is actually going after a real problem. Like, this is not a science project. This is manufacturing. So it's reducing scrap or reducing downtime and thinking about a big, costly problem at one plant, or going big across multiple plants. That's what you want to think about when you first start is, if I tilt the needle by 1% or 5%, does that return 7 figures across a plant or multiple plants? And then probably more importantly, and we learned this in our collaboration with Colgate, is, it doesn't take long to connect to data and run it through a model and predict something. That's several weeks, and, Twin Thread makes that really easy. But then the question is, then what? What do you do then? And what we've learned, and just as much from Colgate as they've learned from us, is think about how do you operationalize. What would, if you could predict density or protein or fat, in advance by an hour, what would you do differently? And how would you then go realize that return? And so that's really what we think about more often. And our pilots are really more of a proof of value. To Warren's point, we want to fail quickly. If we're going to fail, 20% of the time, it's not a good use case, and we want to know that in a couple of weeks. But if we do make it past that milestone, what would we do differently over the next coming couple of months to get that first use case operationalized? And what would you do differently as a consumer of this technology in your operations? That would be, yeah.
I like that, building out those what if scenarios and saying, what would the savings be, or what would the impact be, down the line.
Yeah.
So Darren and Warren, I wanted to ask you on the same line of thinking here, what are some examples of, business level objectives, at the company that you've been able to see benefit from advanced analytics and digital twin?
I can take a quick shot at that and then turn it over to Warren. I think examples are just, we're really trying to understand where our biggest opportunities are. Let's go after our opportunities, and I think especially in our business, the opportunity is really kind of 3 things. If you look at your P&L within a plan, it's absolute material loss, it's labor efficiency, and it's energy usage. And how do you get better at those 3 opportunities? And then that's where you really take those insights of your P&L, of your balance sheet, and then how do you attack those through technology and through digitization? And I believe that's what we're trying to do here. And we're trying, and in pet food, your opportunity is at the conversion process, where you convert from raw materials to finished product. That's where you have a significant amount of labor. That's where you have a significant amount of material loss opportunities. And that's where you're using a lot of energy, especially energy to rework product if it's not right the first time. So really be very specific, very pinpointed with with where you're attacking and where you're going to use your resources, because resources aren't aplenty. You only have a certain amount of them, so get them focused on the right opportunities. And I believe that's how we used analytics to be very, very, very specific with our business level objectives.
And Darren said it very well. And I'll just add to complement that, is that the one thing that we've, on our journey with the various technologies that we are deploying, and in this case, the digital twin, is that we pairing up with GrayMatter in the beginning, we said, well, our objective is to be able to make adjustments on our quality parameters online and in real time, and take that out of the, as Darren had said, take that out of the operator's hands. And then secondarily, we wanted to reduce material scraps on changeovers that require operators to go back and forth to the lab analysis, taking 10 or 15 or 20 minutes to then make these adjustments and make sure the changeover between the formulas are correct. We wanted, so that's a significant opportunity. But the one thing that we then realize, and I think anybody, as you move forward, you're delivering upon the original objectives. But then when you start operationalizing these technologies, you start really seeing not only how do you bring the threads of various technologies together, but then you're looking at the broader view of the opportunity. And it could be both from a financial or a dollar value, or it can also be through just other efficiencies. As Darren said, your energy efficiencies, your labor efficiencies, diverting resources in different areas that you might not have seen before, that there was a need because you were always focused on these other areas that are now being automated out. So looking at the bigger picture, you really start, as you deploy technologies, of course you're looking for those benefits you define up front. But then when you start really looking at the bigger picture, you start seeing that there's a whole lot of other benefits that are coming through that had you not went this route and deployed these smart technologies, you would have never seen. Because again, you're diverting, or your people are focused on something that's, things that have been happening for probably years and years, that now you are, through these technologies, uncovering and seeing what else the opportunity is going to bring.
Absolutely. So this next question, then we'll start to get into some of the audience questions that we've received. But I'd love to get all three of you to weigh in on this. We'll start with Carson. But what do you think is the most common misperception or challenge? Some people have asked about the biggest hurdle, to leveraging digital twins, to enable advanced analytics. Carson, do you want to handle that one? An obstacle or misperception that you often see out there?
Sure. Probably the biggest misconception I think I see is just the approach or the philosophy. And so a lot of people think about this as an architectural problem first. So, let's spend a bunch of time and effort and create a data lake, and let's move all of this manufacturing data into a big database in the cloud. And then we'll hire a handful of data scientists and sort of turn them loose on this data and see if they can find a needle in the haystack. And that's a very long and costly approach. And the data sort of loses its fidelity as you move it to the cloud. They start to take samples and averages and stuff. And machine learning really likes that raw data. And so, and you don't know if the use case is viable that you're going after to begin with. So, our approach is, let's do a rifle shot first. We'll get to the architecture later, but let's go after a single line, a single problem, a single use case. Let's take that data and find out in a couple of 3 weeks if it has value, and then we'll operationalize that first one, and then we'll take a step back based on our learnings in collaboration with the customer, because every customer has different IT influences, and then we'll figure out what the longer term architecture is. But we use the ROI from that first use case to start to percolate and fund that longer journey of the architecture. So I think it's the, move the data and they will come approach, as opposed to actually solving an industrial use case down in a plant somewhere.
Darren, the same idea. What was a misconception you had or a hurdle you encountered, that you saw that you think would be instructive?
Well, I kind of alluded to it during my presentation a couple of times. Really, the what we learned is the digital humans getting to the management of change. I guess I'll call it management of change, and taking what historically has been a process that we've relied on our technicians for, and then asking them to change their behaviors and trust in models, trust in the data, and back away from those decisions. Is really, really tough, because the human beings, I think we all do it. We get in our cars and we want the temperature. We don't trust that 70 degrees on our temperature. We want to push it up really fast so we can get there, so we can get it to 70 degrees faster, or whatever it is, and don't trust the models behind that number. And that's what humans do. And the faster you can automate the process, the faster you can just operationalize it to where it becomes just part of their everyday, and they're not seeing it as something different to where they struggle with that change, I think was our biggest learning, and quite honestly set us back months to where we had to find ways to really again, operationalize it and make it part of their process, and not something that they saw as change. And that was easily our biggest learning.
Warren, was there one that you recall as well?
Darren said it perfectly. I mean, change management is huge. Changing the human factor there and getting people to understand, believe, and trust the technology. But I would say on a broader base, you need to partner with those that are going to, those companies, and whether they're big companies or whether they're startups, you need to partner with companies, with these technology companies and platforms that are going to really show that interest, because, as it's not all going to be quick and easy and deploy and let's move on to the next customer. And you got to identify those companies that are willing to invest their time, their resources, their technologies in you as a partner, and not just trying to sell you that shiny object. And unfortunately, you learn by trial and error, and that's what I would say is that, again, on a big looking at the landscape, it sometimes you're going to come across those that they just want to sell you a product and then get in, get out, and move on to their next customer. And I think what we've seen with GrayMatter and TwinThread is that they share, number one, they share our vision. So they entered it knowing that, hey, we've got this technology, we know it works, it's in the field in other industries and other companies. But you've got Hills and Colgate have a very different process model that we've got to make sure we get the right data input into it, get the right framework set up, dedicate the resources, and knowing that it's not going to work from the first get-go. We're gonna, as mentioned, we're gonna fail in some cases based on just miscalculations or whatever. And but we're gonna work until we get this right. So that would be what I would add as a bigger picture on how you identify and deploy technologies that are going to improve your overall process and your end-to-end supply chain.
Thanks for that, Warren. All right, so I want to give our audience a chance to have some of their questions answered, and these first few relate to the presentation that Darren and Carson gave. So the first one, Prasanna is asking, is it possible or why is it not possible to do a quality check before the extrusion process and then after while it's being transported? So is there a way that you can kind of get into that question a little bit, Carson or Darren, to talk about when it's possible to start doing those quality checks, basically?
Yeah, I can answer that. So, okay. So the most difficult, so it's not possible to do a full quality check until you leave the cooler in our process, because the product changes throughout. The dryer impacts the moisture of the product. It impacts the density of the product. The enrober impacts the fat, impacts various parts of the moisture, and then the cooler also will impact it. And so that's the issue. You got to get to the end of the cooler to get a really good quality check. You can do quality checks along the way, but they're never going to be complete until you get out of the cooler. And so that's the challenge. That's when a lot of times you start making your biggest modifications to the process 50 minutes later.
Great answer. Okay. Yeah. So Frederick is asking, do you have some real examples of, digital twins for extrusion and the actual cost benefits that have been realized? Do you have any examples that you're able to share with the audience? Yeah.
I guess I'll try to answer the question this way. We have real examples. We're doing we do have digital twins built into our extrusion process right now that we're using. We are still in the process of fully quantifying the benefits, and we are seeing statistical improvements. CPK is from a moisture and a density standpoint is improving. We're seeing less reliance on the operators, and I think the labor hour per ton opportunity that we have, it's difficult to realize that until you take that manual quality check away. And so we need to finish automating the quality check, and then we'll definitely see huge labor hour per ton benefits. But right now what we're seeing is CPK benefits, which translates directly to absolute material loss advantages. Very specifically, startup scrap is much lower, and we have that quantified. So yeah, we're quantifying benefits.
Yeah, and with today's supply chain issues, that's absolutely huge. So Carson, this one might be a good one for you. How close can you get, or do you get to real-time data flow? What kind of intervals are you talking about when you're collecting data? What's the data resolution, on projects that you're working on?
Yep. Excuse me. It really depends on the process, but if you think about predictive analytics, predictive downtime, predictive quality, we're predicting out into the future. Sometimes it's 50 minutes in this case. Sometimes it's 2 or 3 hours. If it's an 8-hour batch, it's late in the batch, might be 6 hours or so that we're predicting ahead. And so there's a whole different class of analytics that's closed loop, PID control, less than 10 milliseconds and that kind of stuff. That's not what we're going after today. We do have plans to do that, but we're predicting something 10 minutes to 2 days in advance. It's okay if it takes us plus or minus 15 seconds to get that there. On the raw data coming in, however, we love as much resolution and as much history as we can get, and as much different data sources as we can get. We can handle infinite amounts of data ingestion, and the data can be down at once a second, once every 50 milliseconds if you want, and that just makes your models better when you're actually predicting. And then on that extruder question, we do a lot of food and beverage extrusion. We also do a lot of materials like polys and plastics, and there's a lot of different extrusions examples that we have. So it seems like that's the number one thing we connect to is extruders, regardless of the product that's being made.
Well, and they make cool digital twins on the screen too.
They do.
Yeah. So Nelson is asking, this is kind of an interesting question. Is there any region in the world where the use of digital twins is more prevalent, more developed, and why that might be? Colgate, obviously a global company. Have you seen that, Darren or Carson?
Darren, you want to take that one first?
Well, it would be difficult for me to answer that question. I don't think. I mean, so we've started in North America, and now we're pushing out. I don't know. So that's my experience. So I wouldn't be able to talk to it at this point from a global perspective.
Okay. So
and
another.
That's the same here, Jeremy.
Okay.
We're North American based, so we follow companies all around the world, but they typically start in North America. That might be a question we can follow up on at the broader level.
Certainly. So you guys have touched on this a few times, but I think it's good to come back to because this puts a bit of a finer point on it. Carlos asks, how much training, did operators need for implementing the solution for digital twins? Darren, do you want to field that?
Yeah. So, I mean, I think that's the operationalizing piece. That's the challenge. And I think the better you can operationalize it, the less training that's required. And the simple fact is our operators have little to no training necessary because we've made it part of their process. And so we've helped them understand, hey, instead of you making adjustments to the dryer or you making adjustments to the cooler, we're going to do that. We have a program that's going to do that for you, and you can see what's happening. We'll build it onto your screen, but there's no need for you to do anything differently. As a matter of fact, you can step away from those decision making a bit and just keep your eyes on the process. And so the better you can operationalize, the less training that's required and necessary, other than just an overall education of what's going on, of which we did.
Yeah, and this is where it really takes the leadership. It takes the executive sponsors to really drive that change, because the first thing that the operators are going to do is reject it. You're not going to tell me how to make dog food. I've known more about this. I've been operating this thing for 11 years. You can't tell me. And then, they make a bad batch, and the management has to come in and say, listen, we're trying some new technology here. It doesn't mean anything negative. We're just trying some new stuff. Would you at least try it? And then they try it, and they see the scrap go down, and they start to believe, and then the key is to make that simple. So in most cases, we're driving the recommendations back into the user interface that operator has been running with for years. In this case, Wonderware, but any HMI, any user interface that they're familiar with, we drive the recommendations right back into their familiar HMI to operate with. But it takes a few tries. We've learned that it takes that executive sponsorship to drive that change, and Colgate does that very well.
And I'll just add to that. Darren and I were in Emporia, Kansas last week. We took a walk through one of the plant there, and Darren showed this, I think, on his second to last slide, where every making platform had an HMI on it. It's still there, but that's where the operators had to go and make any adjustments, work on any alarms or whatever. Today, and it was in the picture that Darren showed, I think that might have been Emporia, was that today the operator is now sitting in a control room with that situational awareness. He or she's got, if I remember, 6, 7, 8 screens that are basically, we've pulled all the data, the team has pulled all the data in, including the digital twin, because we looked at that as well as they roll that out in Emporia. But that's brought all that into one location, one operator, and then with the use of a walkie-talkie, they are communicating to the various areas if there is an alarm, right? So now you don't have operators running around on every platform addressing something or checking something. They are getting that data so they can use their time more effectively in other areas, and then only respond when that singular point of contact it calls you and says, hey, we need to check this. So I think that change management, and through that executive leadership, Darren, the plant management team there, has really driven that change, because you seeing is believing, and I've not walked through that plant since COVID. It's been probably really 3 years the last time I was there. and now seeing this transformation, and that the operators are not only adapting, but they're living it, and they see the benefits, is something to really see on the ground there. So I think it is working, and they've done a great job doing that.
Well, that's great to hear, Warren. And I really want to thank everybody for sharing their story today. Carson from GrayMatter, Darren from Hills, and Warren from Colgate-Palmolive. I think we've had a great discussion. The presentation was amazing, and I think we took some great time to really get through some of the questions from the audience today. So I appreciate you guys sharing everything.